New Zealand Biochar Industry Group, and I'm also the business development lead for Metamorf Engineering. So you'll see some flyers on your desk about our technologies that we sell to in lots of industries, got lots of interest, and we've got lots of projects going on, and we also sell biochar on behalf of our clients. And excitingly, you know, we are in discussions with Western Murray Landcare Group about distributing our biochar in this region. So, and Roger's going to talk about that shortly. So there's some really good things going on. Now I'm just going to, maybe you'll need to do the slides. That's all right. I'll just rather see what I'm talking to next, but I'll do the next slide with you. So we have a CEO of the Australian New Zealand Biochar Industry Group. It was John Coyne. It's now we've got a new person who is working with us, and he is Patrick, and he is working heavily on the ACCUs and also on the standards at the moment, and lots of advocacy to the industry group, and I'll talk a bit more about that as we go through. Next slide. Just next slide, this is what I'm going to cover. So firstly, I just wanted to go back a little step about biochar and what it does. So the production of, we've talked a lot about the use of biochar today, and we've talked a little bit about the production of biochar. So with these continuous systems, they supply not just the biochar and the carbon in the biochar. So when you actually put biomass through a system, what it does is it limits the oxygen. When you have oxygen, you combust and all the carbon goes up into the atmosphere. When you limit the oxygen, you pyrolyse and all the carbon gets trapped into the biochar. And the higher the temperature, the more the biochar goes through a popcorn-like effect where it expands and it has more surface area, more porosity, and more charge on the surface area. So there's those three things that go up as temperature goes up. And when you limit the oxygen, exciting things happen to the product. It traps the carbon. And I think that very ethos is why we're all here, because we need to recycle carbon and get it back into the soil where it belongs and stop it from entering the atmosphere, contributing to greenhouse emissions. But when you use biochar, it's got all these other carbon saving and nitrous oxide reducing benefits as well. But the other side of it is when you produce biochar, you've got three revenue streams through these continuous systems. You have the biochar, you've got the carbon in the biochar, but you also have it depends on the system itself. So with Metamorf systems, we produce thermal energy. So we actually use the syngas back in the production of the biochar to control the quality of the biochar, and then we have significant thermal energy available that can be used to replace. It can be used in boilers. Sorry, it's a bit distracting you too. Yep. Can be used in, if you want to talk, just, it could be used in boilers. So the thermal energy can be used in boilers, or it can be used to replace electricity. But there are other systems like Echo who have syngas available, and that replaces natural gas and liquid gas. And there's other systems that are actually looking at producing renewable fuels, like aviation fuels. So when you actually produce syngas, which is so everything that is, carbon stays in the biochar. Everything else comes off as a gas, and it's syngas. That syngas in Metamorf systems is used to control the quality of the biochar, and instead we produce thermal energy, and that can be converted to electricity. But others, the syngas is quite diverse as well. So that can actually be used to create ammonia, renewable fuels, replace natural gas. And it's significant. So for us, for example, for every 5,000 tonnes of biomass we pyrolyse, we produce around $300,000 to $400,000 worth of energy value. So for every 1,000 tonnes, you're producing $300,000 to $400,000 in energy value, or as a replacement for fuel or something else. So it's very timely as well. There's grants out for this sort of technology at the moment, which is trying to encourage it to develop. That's my role as chair, to help develop the industry. There's other technologies overseas that are producing renewable fuels and things. Next slide. But for farms, there's also large corporate farms are looking at using these machines on their own farm. In fact, we've just sold one and we've commissioned it on a cereal farm that is converting their cereal to biochar and carbon dioxide removal. So I just wanted you to remember these properties, because as the temperature goes up, this graph shows you, as the temperature goes up, we increase the surface area, the porosity, the charge, the holes in the biochar, if you like, and the electron mediating surface. Now, we know that for different purposes, you can make biochar anywhere along this scale for different purposes. And so we're actually, as other technology providers are doing, are making fit-for-purpose chars. If you want a feed quality char, you might be up this end. If you want a soil quality char, you might be down here. And then it also changes depending on the original feedstock. And so it's, as producers, we are needing to understand this process, as we all have R&D machines, a bit like what our previous speaker talked about. Earth Systems ran through a lot of different feedstocks through their machine to work out the optimum production for the feedstock and the end use. And that's what most of us do, to be able to make biochar and sell it and market it for the end use. Next slide, thank you. So I just wanted to go over what the why for the whole industry group. The industry group plans to pyrolyse 50 million metric tonnes annually through all the different technologies like Eco2, Metamorf, Earth Systems, some of the others you've seen, to biochar plus carbon dioxide removal, because it's deemed carbon dioxide removal because we're trapping the carbon in the biochar and stopping entering the atmosphere, and emission avoidance, whether it be through thermal energy, renewable fuels, syngas, whatever. So each of these are worth, if we achieve this goal, it's worth a minimum of $6 billion in biochar, plus $3 billion in carbon dioxide removal, plus a minimum of but I think it's more than that, $1 to $2 billion in the thermal energy or emission avoidance value, I would suggest, right? So anyone that purchases this technology to use it, and this is a extra step in the whole farm resilience for corporate farms, is you can actually get in on that bandwagon and make revenue from the biochar, the carbon in the biochar, and if you can find a use for the thermal energy from the thermal energy as well, then you can actually use the biochar on your own farm to benefit your own farm by reducing your fertiliser uses, improving efficiency, increasing yield, and improving your soil natural capital. And in fact, that's what a cereal farmer did by purchasing one of our technologies. Best 3 years in 10, instead of buying a new header this particular season, they purchased one of our technologies to invest in their farm natural capital. So I just wanted to reiterate that at the moment, the carbon dioxide removal, yes, we're chasing an ACCU to recognise the carbon in the biochar, but at the moment we actually sell it on the voluntary market for $200 a tonne. So the only reason we need an ACCU is for the Australian government to count it as part of their greenhouse or net zero strategies. At the moment, we're getting far better dollar on the voluntary markets, and there's a number of those available. So next slide, please. Next one. So I just want to talk a little bit about Metamorf, because the background of Metamorf is renewable energy and cogeneration. And then they started working on pyrolysis technology and realised the benefits of that you can actually produce renewable energy through pyrolysis. So that's now all we do. And we do the whole thing. If someone says, I'm interested in a biochar technology, you can come to me. We go out to site, we have a look at your feedstock, and if you've got any thermal energy use, and then we can quickly give you an idea of technology pricing and payback, which is really quick. But we design the thermal energy fit for purpose for site, the feed systems for the feedstock, and all sorts. And then we also help sell the carbon dioxide removal, and we also help sell the biochar. And we can also help you achieve soil carbon accreditation as well by increasing the soil carbon. Next slide. I think I've covered off on that. So we've just got a factory in South Australia. We've got two technologies, the char cell 3 and the char cell 4. The 3 input is 5,000 tonnes of feedstock throughput, producing about 1,000 tonnes of biochar, up to about 2,000 tonnes of carbon dioxide removal, and about 29,000 gigajoules of thermal energy. Each of these revenue streams is worth around $600,000 per unit minimum. Then we go to the char cell 4, which is 4 times bigger, 20,000 tonnes of feedstock throughput, 5,000 tonnes of biochar, and each of these revenue streams is about $4 million. So very fast payback on the technologies. You're looking at a setup cost of around $1 million, give or take 20%. This one around $2 million, give or take, this one around $3 million, give or take 20%. But the paybacks, even without the thermal energy, you're looking at about a 2-year payback, really quick. Then you're starting to generate $3 to $12 million of revenue annually from the machine. So that's why we have over 300 inquiries for the technology, with growing inquiries from farmers or corporate farmers with large amounts of feedstock, or things like rice mills or sugarcane mills or almond hullers, but the biggest use and the biggest amount of feedstock available in Australia is actually wood chips. Second amount is actually cereal straw. So for us at Metamorf, our biggest number of inquiries are from timber mills, and the second amount is from cereal straws. Our, approach to the industry is using clean feedstocks, because we want to get runs on the board that way. And then we're also starting to look at some of these more contaminated feedstocks as well, which may have a different use, it may be industrial use. Next slide, please. That's just a little bit about the history, but we're really proud. We're just commissioning 3 char cell 4s at the moment. One of them is in New South Wales, where the biochar will be coming from. That's been commissioned literally this week, and there's biochar available for the region, which is really exciting. There's 2 in South Australia. They've just actually put one into a cereal farm, which I'll talk about. And we did actually do some initial early days work on some of the HoloFresh work and learn a lot from that process before we went on to the char cell 2s and 3s that we have available now, and 4s. Next slide. So I wanted to talk about this case study, which is on a cereal farm. 5,000 tonnes per annum of cereal straw on a 4,000 hectare farm. So it's a bit between, they have to leave 25% of their original biomass. They take off the head, so it's the trash in between. So they're actually taking that off. Normally they would bale that. So they take it off and they bale it. It's going into our machine, and it's giving them 1,000 tonnes of biochar, 2,000 tonnes of carbon dioxide removal, and 30,000 gigajoules of thermal energy. If they were to sell the biochar, $800 a tonne is a very low price. I've just put in a very, very low nominal price. They generate about $800,000. The carbon dioxide removal we expect is about $400,000 they'll get as a payback. And then if they use the thermal energy at $15 per gigajoule, it's around about $450,000. However, they're actually not selling the biochar. They're using it on their own farm to reduce their fertiliser inputs and apply it with their synthetic fertiliser and increase their yield and increase their soil carbon as well. And we've shown them that the payback by using the biochar on their farm to improve their soil natural capital will achieve them more revenue than this or more savings. So, and I'll show you some of the reasons why as we go. So that machine has been commissioned, and we're actually working with some researchers doing trials on a farm, trials with local farming systems groups. So it's in the mid-north of South Australia. I do want to say that we actually are in very close talks with a local rice miller with a similar case study. And so there may be some biochar available locally, and I do have some lovely test rice hull biochar available here. And as we talk about applications of biochar, and if you open this, you're welcome to, do it at your own risk. You'll get biochar on your fingers and on your, but you're welcome to play with it and pass it around. So we'll get into, you can play with that as we get into how to apply biochars. So next slide, please. This is a little bit of a summary of what Russell's talked about and some of the other speakers about the benefits